Welcome back. In stage 3 of our Arduino traffic light control system project, we're adding night mode using an ambient light sensor. When it gets dark, the system switches to a flashing red light and displays a safety message on all LCD screens. This adds realism and safety awareness to your intersection simulation. We'll be reusing all of the components from the previous stage of the project and adding an ambient light sensor and a 10K ohm resistor. We simulate a four-way intersection with synchronized traffic lights and pedestrian LCD signs. The north-south and east-west traffic lights operate on opposite schedules. Each direction has an LCD screen that displays pedestrian messages based on traffic light phase. The LCD screens use I2C communication, connecting to the Arduino via SDA and SCL pins. Each LCD also requires power and ground. The ambient light sensor collector pin is wired to 5V. The emitter pin is connected to analog pin A0 and is wired to ground through a 10K ohm resistor. This setup allows the Arduino to detect light levels and switch to night mode when it gets dark. The code uses millis for non-blocking timing and a phase control to control the traffic light cycle. The LCD messages are updated using a helper function that checks for changes and refreshes the display only when needed. Each LCD screen requires a unique I2C address, for example, 0x20, 0x21, etc., which must be specified in the code so the Arduino knows which screen to send the message to. This allows each screen to display direction-specific messages independently. The traffic light logic is managed using a switch phase structure. The switch statement evaluates the current phase of the cycle, and each case corresponds to a specific configuration. This modular approach makes the code easy to read, expand, and maintain. When the ambient light drops below a threshold, the system enters night mode. In this mode, all red traffic lights flash every 500 milliseconds. The LCD screens display check traffic. Normal traffic logic is paused until daylight returns. Let's check our code and start our simulation. So it starts off in night mode. We can see the red lights are flashing. We'll use the sensor to simulate some sunlight. Let it go through a couple cycles. Try adjusting the night mode threshold or changing the LCD messages. Can you add a buzzer that makes noise while the red lights are flashing? Or simulate street lights turning on? Share your ideas and code in the comments. If you're following along, consider picking up an Arduino starter kit. It includes all the components we've used so far and many more to challenge your learning and experimenting. Check the description for links to kits and components. That's it for stage 3. You've added night mode with ambient light detection and flashing red lights. In stage 4, we'll use a potentiometer to simulate different traffic volumes and dynamically adjust the green light durations based on how busy the intersection is. It's a great way to explore adaptive traffic systems. Don't forget to like, comment, and subscribe for more Arduino tutorials.